Alright, Salty Sharps, let's rock. How do you do this quantum mechanics realistically? The transistor, the transformer, the resistor, basically a manufactured 99.9 pure copper wire. That is what one is. And we're going to get into that quantum mechanics here in a second because technically speaking, I'm this collector instead of the emitter where this properly runs its circuit. Let's just say because close geometry, that's what that is. This is this high line. All right, so that makes sense. There's this little wire and this little wire. They are square into the system. Doesn't need to be a hamster or a battery, right? Power source coming in from whatever operating system that correlates to. That I know it is negative delta, little delta, before we get into sine and cosine and the rest of that z operation and the third order, right? Because I got to get it to blinkety a little light bulb in a sequence and all that ball wave. Yes, true. That is right to the emitter. So in here, I want you to keep that in mind that essentially at the Planck level, as a chemist here, it's more important to be a defined model of 1. Is it 10 to the negative 35, I think is what it is, 32, something like that, maybe even 42, maybe quantum physicist, but for the most part, E equals mc squared, one of the most efficient ways to just murder a rookie right there. I need the form of energy, some ways, all the ways. And all of those M theories are traveling causal to make these things, again, blinkety in an event time frame with its geometric housing. Because then you get the hydrogen and helium Bohr model of emissions and absorptions to the Smith chart, which is more, as a logical standpoint, ones and zeros, yes, but no. Running around the classroom can have that effect about, well, why do I get up in the morning, train kids to blinkety light bulb? Because overall it's its own heat index on being a teacher. So button, and again, that's the current that this is 5 volts. We've thinned that out, whether it be at the NVIDIA chip level, you're getting in there with a microscope, and this is one individual section where it could be 1 volt, or something more efficient to the bond calculator that you serve for a penny of stock, 10 times 1,000, 10 cents, 5 cents, 5 cents, 10 cents, a dollar, $5, and then at what multiple you sell out at. Is it a 1.1 pennies, or well, a penny point one? Anyways, so yeah, that's one of these figure fours. He's just applying it over here because yes, chirality. Yes, that is both of those circuits are 1, and this power source line inside here says yes. I could check it there, and it's going to be 5 volts. 1, bang, got it, fantastic. And on the first system, there's still a chiral universe to that, n1 half. That is to say, well, what if this here little transistor on there wasn't configured? What is it? EBC, reading it right ways this way. It was the other way, whether it be backwards when you put it on there. That's a third or 3/4 of some of the problems, and the nature of that chip, high and low, right? If I'm going to build out a bones mechanics to logic gate, right? Here's a piece of wire. That wire in this case will thin out this charge, hamsters, batteries, 9 volt power source, copper wire, solid, does a good job as far as a semiconductor or a reluctance feature. I know what you're thinking, resistivity, but no, magnets, so reluctance. But yeah, magnet, positive, negative, and then you make some geometry out of it, right? And then you get that thing, all the squares, and you spin this thing in the middle of it. You just wing it around inside there, and maybe there's a way to passively that does have air resistance and nitrogen in gravity, but for the most part, that's an approximation of the zero. For now, in the stone mill, how we load and unload that saw in the future may change. But as far as the wires on this thing and the button you need to press when you need to press it, all that makes one. That is one or not one. And again, being that 1/2 version of that chirality, or that 3/4, 1/3, 2 units, is like, well, I checked it again. And then the third time it actually worked. That's algebraic series, A, B, and C. It starts to run off at the tau level of the floating point number, range, and precision. Electron would be heavy left-hand rule, but it's based up of all the electrons in the universe that could have been Larry screwing around in the middle. Like all of that. Let's just stack dimensions on Terminator Gambit inside of here. And I want you guys to do that. I mean, not that this isn't a great kind of bones mechanic. You want to start doing some notes like this. You want to start referencing your features in such a way that maybe looking at this now, you want to take the Gaussian log table, I think is what it is. It may not be Gaussian, it might be Fourier, one of them like that. But you want to actually do that with your bond calculator. Why? Because this transistor and the transformer are kind of like superposition with each other. It's definitely a 1 or a 0 given what you got going through it, if those things are lined up. When the logic writes that thing out, this is what it actually equals, and this is E, right? This is the general relativity of what MC 1/2, 0 to 1, when 1 and 0 want to bang that around in a much cleaner multi-metrics because it gives it limitations. From here, that logic gate is still not doing anything that I want it to do from that power source to 0 to 1. In this case, it is a little negative delta. Is a great way to express that. It's just photons on a wire, don't quite know, they're just going along with it. Come out here, 5 volts, 6 volts, size 9 boot, whatever. And when things are 1, orders of understanding who has orders of 2 and understanding who has it 1. And usually something like this is a trait characteristic from one of those other functions that you got to keep your eye on.